Hello, ladies and gentlemen. There was a problem in class today, Wednesday, August 4th, that I worked out, and I did not work it out correctly, and I want to set the record straight. This was problem number 12 in section 5.3, which is on page 269. So page 269, number 12. They indicate to us that the tangent of some angle theta is equal to 5/12. And they indicate that theta is in the first quadrant. And they want us to, knowing that, they want us to find the secant of 2 theta. Okay. Now, what I indicated in class, ladies and gentlemen, was an error. If the tangent of theta is equal to 5/12, I indicated, and we know from the ratio identity that this is equal to the sine of theta over cosine theta. At that time, when I was going over this problem in class, I indicated then that the sine of theta must be equal to 5, and the cosine of theta must be equal to 12. This is incorrect. Let me show you an example. If we have our 30, 60, 90 triangle. And of course, I label the sides, the way we labeled them in class. If we look at the tangent of 60 degrees, for instance, we know the tangent is opposite over adjacent. So this will be the square root of 3 over 1. But later on, because the tangent is a ratio of sine over cosine, the sine of 60 degrees over the cosine of 60 degrees, you cannot say that the sine of 60 degrees is equal to the square root of 3. And the cosine of 60 is equal to 1. That's not the case at all. The sine of 60 degrees is going to be the square root of 3 over 2. And the cosine of 60 degrees is 1/2. So be careful. When you have the tangent of some angle equal to a ratio, you cannot say that the sine of that angle is equal to the numerator and the cosine of that angle is equal to the denominator. So be careful there. So to do this problem correctly, what we should do here is, knowing that the angle theta is in the first quadrant, is let's build our right triangle in the first quadrant. So here's theta. Now we know tangent is 5/12, so that's the ratio of the opposite over the adjacent side. Therefore, by the Pythagorean theorem, then you would conclude that the hypotenuse has a length of 13 units. Now, to find secant of 2 theta that we're being asked to find, we know this is 1 over cosine 2 theta by the reciprocal identity of the past. But ladies and gentlemen, we just learned today the double angle identity for cosine comes in 3 forms. So we can tap into one of those 3 forms. And the form I'm going to tap in for the cosine of 2 theta is cosine squared theta minus sine squared theta. Now, we can use a triangle we build up here to determine what these values should be for these trig functions. Cosine of theta is 12 over 13, adjacent over hypotenuse side. So 12/13. Now we're going to square that. The sine of theta is the opposite side over the hypotenuse, so that'd be 5/13. And we square that. Hence, what we're going to have is 1 over, and 12/13 squared is 12/13 times 12/13, which is 144 over 169. 5/13, which is 5/13 squared rather, which is 5/13 times 5/13 is 25 over 169. So this gives us a complex fraction, which is 1 over 119 over 169. And so, ladies and gentlemen, the answer should be 169 over 119 for problem number 12 on page 269. This should be the correct answer for problem 12 on page 269. I do apologize in class with trying to say that the sine of theta is 5 and the cosine of theta is 12. This is not correct at all. That's bogus. Can't say that. And so this is the correct way the problem should be done for number 12 on page 269. This is the correct way. Okay, hopefully that clarifies things for you, and do make that change in your notes. Thank you.